Consider the situation shown in figure. Suppose a small dielectric field E exists in the space in the vertically upward direction. Okay, electric field is existing. So we will discuss. So hint is given. What is electric field? Okay, electric field is given in upward direction, and the upper block carries a positive charge on its top surface. Okay, so same question, the previous question we have to consider. So suppose this is the diagram. Okay, so here it is, friction is mu, and here it is smooth. This mass is m, this mass is small m, and it says that a small electric field E exists. A small electric field E exists in the space in the vertically upward direction, and the upper block carries a charge Q on its top surface. So here we have charge Q also. We have charge Q on its surface. The friction coefficient between two blocks is mu, but the floor is smooth. What is the maximum horizontal force can be applied without disturbing the equilibrium? So how to solve this question? So here again we will write the forces. So if we write the forces on upper block, so what are the forces? So for small m, if we write the forces, so one is the mg downward, other is the normal from the lower surface, mg downward, normal from lower surface. Then there will be a force due to charge. So the force on a charge Q by electric field is F equal to Q in the direction of E. So if electric field is in upward direction, charge is Q, then there will be an electric force that is called Q into E. So that is given in the as a hint. So this extra force is acting. So and then when you pull it, when you pull this, suppose when you pull it, there will be a friction force developed in backward direction, and on the lower object there will be friction force in this direction. Okay, so friction force is acting here. Okay, so we can write the equation. So if we write the equation, how much we can write equation? So for equation will be first we write vertical direction. So normal plus QE Q equal to mg. This is for the small m. Okay, so normal is coming how much? Mg minus QE. So this is a norm. The normal has decreased. So why it has decreased? Because of this extra force. Because of this extra force, the object has become little bit lighter. Because of this extra force, the object is not pressing the lower surface with the same value. It is pressing with lesser value. Okay. So now normal we have got. So what will be the value of friction? The friction, since it is about to slide, the friction will act as maximum value. So mu times normal, that will be mu times mg minus QE. Okay, so this is the value of friction. Now we will write the horizontal direction equation. Horizontal equation, the tension in forward direction and tension in backward direction. The object will try to move what? Upper object will try to move leftward. So we will write F is balancing that tension plus friction. Okay. Now similarly we will write for capital M. For capital M, if we write, it will have tension and then backward direction friction, or tension equal to friction we can write. Now from this equation, equation 1 and 2, F equal to small f plus f. So capital F is 2 small f. Okay. So 2 small f is 2. And what is small f? Small f is, we can write mu mg minus QE. Mu mg minus QE. Okay. So this is the value of applied force. So this is the minimum force which we need to apply in this case. Okay. So in this way we can solve.